Hello everyone. Good morning, good afternoon, good evening, depending on where you are listening from. My name is PromiseUkamaka. I'm here to talk about the red blood cells. Yes, production of red blood cells, which is also known as erythropoiesis. Red blood cells are produced continuously in the bone marrow of certain bones. Yes. In adults, for instance, the principal site of red blood cell production are the marrow spaces of the vertebrae, the ribs, breastbone, and pelvis. It is important to note that within the bone marrow, the red cells is derived from a primitive precursor, which is also known as erythroblast. These erythroblasts is enucleated cells in which there is no hemoglobin. So the primitive precursor of the red blood cells has no hemoglobin. The proliferation occurs as a result of several successive cell divisions. During maturation, hemoglobin appears in the cell and the nucleus becomes progressively smaller. After a few days, the cell loses its nucleus and is then introduced into the bloodstream in the vascular channels of the marrow. So it is important that we know that in production of red blood cell, the precursor, the primitive precursor, which is erythroblasts, it does not have hemoglobin. So as the days go by, the cell loses its nucleus and is then introduced into the bloodstream. So almost 1% of the red blood cells are generated each day, and the balance between red blood cells and the removal of the aging cells from the circulation is precisely maintained. So what I'm trying to point out here is that in production of red blood cells, there is a balance. The red blood cells which are produced in the bone marrow, it's not just being produced without control. Of course, as we go down, I'm going to talk about the lifespan of the red blood cells, which is 120 days. What happens to the red blood cells at the end of these days that it lives? So another thing we need to know is that when blood is lost from the circulation, the erythropoietic activity of the bone marrow increases until the normal number of circulating cells has been restored. For instance, in case of injury, if there is blood loss through injury or trauma or hemorrhage, the activity of the bone marrow increases. Why is it increased? So that it will compensate with the blood that is being lost. In a normal adult, the red cells of about half a liter, that's 1 pint of blood, are produced by the bone marrow every week. Oh, this is wonderful. This is wonderful. Every normal adult is expected to, the bone marrow is expected to produce 1 liter, 1 pint of blood every week. So a number of nutrients are required to do this. Yes, for the bone marrow to do its work efficiently, you have to give it what it needs. Although God provided everything that it needed to do the work. All right. Some nutrients are the building blocks of which the red cells are composed. For instance, amino acids are needed in abundance. We need a lot of amino acids for the construction of proteins of the red cells, particularly hemoglobin. course, we know that hemoglobin is very important. We have the heme part and the globin part in production of red blood cells. It is important to note that about 1/4 gram of iron is needed. That's 1/4 gram of iron is needed for the production of a pint of blood. Other substances required are they are required in trace amounts, but for the iron part, we have 1/4 gram of it. So important among these substances that are needed are vitamins like riboflavin, vitamin B12, folic acid. Folic acid is necessary for the maturation of the developing red cells. Vitamin B6, also known as pyridoxine, is also required for the synthesis of hemoglobin. So these are factors that are necessary for the production of red blood cells, for the bone marrow to do its work efficiently. It is pertinent to note that secretion of several endocrine glands influence red cell production. Yes, if there is inadequate supply of thyroid hormone, the production of red blood cells is retarded. And when the production of red blood cell is retarded, anemia ensues. Yes, anemia ensues. Anemia is when we talk of anemia is a disorder of the blood. When the blood has a reduced ability to carry oxygen due to a lower than normal number of red blood cells, or when there is a reduction in the amount of hemoglobin. That is to say that anemia is a condition in which the number of red blood cells or the hemoglobin concentration within them is lower than normal. So when you check the hemoglobin concentration, the number of red blood cells, when it is lower than normal, we call that clinical case anemia. Although there are different causes of anemia and there are different classifications of anemia, but that is not our major interest in this study. So we've talked about the secretion of endocrine glands like the thyroid hormone as a factor that can suppress or retard erythropoiesis, which is production of red blood cells. Another factor that can increase red blood cell production is the male sex hormone, testosterone. Testosterone stimulates red cell production. We looked at endocrine glands. If there is inadequate supply, erythropoiesis will be retarded. But if there is normal supply, adequate supply, the erythropoiesis will not be retarded. Then male sex hormone, testosterone, stimulates production of red blood cells. This is why the red blood cells of men are higher than that of women. Yes. And apart from that, the women, normally there's a blood loss, there's a menstrual cycle which leads to a blood loss every month. For men, they don't have menstrual cycle. Meanwhile, their male sex hormone stimulates the red blood cell production. So the capacity of the bone marrow to produce red cell is so enormous. Yes, When stimulated to peak activity, when stimulated, for instance, if there's a blood loss and there's a signal sent for production of erythropoietin, the activity will be increased. So when the bone marrow is stimulated to produce more cells, when provided with adequate nutrients that are needed, the marrow can compensate for the loss of several pints of blood per week. Yes, if there is, I earlier mentioned that 1 pint of blood are produced by the marrow, by the bone marrow, for a week, by week. Hemorrhage or accelerated destruction of red blood cells leads to enhanced marrow activity. When there is blood loss or hemorrhage, the bone marrow will be at its peak. It will keep producing. Why is it producing? To compensate for that blood loss, so that the patient will not bleed to death. So that's how God made it. That's so wonderful. The marrow can increase its production of red blood cells up to 8 times than the usual rate. After that, if blood loss continues, anemia develops. If the bone marrow kept on producing, is at its peak of its activity, and there's continuous blood loss, if it continues that way, anemia might ensue. So the important thing is that if there's hemorrhage, the cause of the hemorrhage has to be controlled, so that the blood loss will not, the cause of hemorrhage has to be handled. If there is injury, if there is blood loss, the cause of blood loss has to be handled, so that there will be no continuous, the patient will not continue to bleed and possibly resulting in case of anemia and maybe subsequently death. The rate of erythropoiesis is sensitive to the oxygen tension of the arterial blood. Yes, if there is hypoxia, for instance, the sensor, there will be a signal that is sent to the kidney. That's where the erythropoietin is produced to make more erythropoietin, which now enhance the production of which now leads to production of red blood cells in the bone marrow. When oxygen tension falls, more red cells are produced. You see it? When there is hypoxia, more red cells are produced, and the red cells increases. Yeah. For this reason, people who live at high altitude have higher red cells counts than those who live at sea level. So that's those of them that live at high altitude in the mountain, their red blood cells are always higher than those who live at sea level. The rate of production of erythrocytes is controlled by the hormone called erythropoietin. You might have heard me mention erythropoietin. Erythropoietin is a hormone that is produced by the juxta glomerular cells of the kidney. Yes, that's where it is produced. When the number of circulating red cells decreases, or when the oxygen transported by the blood diminishes, there's a signal. There's a signal. In fact, it's seen as unidentified sensor that detects the change. Oh, God is wonderful. That is how He made it. Once there's an issue, once there's hypoxia, or something tells the body that the red cells, the circulating red cells are decreased, this sensor will be sent. So that the production of erythropoietin by the kidney is increased, because it is this erythropoietin that is a hormone that is in charge of production of the red blood cells in the bone marrow. This substance is often then transported through the plasma to the bone marrow. So once the erythropoietin is produced by the bone marrow, once the erythropoietin is produced by the kidney, it will then be transported. What transports it is the plasma. The plasma transports it to the bone marrow, where it accelerates the production of the red blood cell. You see, that's wonderful. So if there's any issue, a signal will be sent to the kidney so that erythropoietin will be produced. Once erythropoietin is produced, the plasma will transport it to the bone marrow so that there will be increased production of the red blood cell. Oh, this is wonderful. The erythropoietin mechanism operates like a thermostat. It doesn't waste time. Once there's an issue, bam, it gives a signal. It increases or decreases the rate of red blood cell production in accordance with its need. The erythropoietin cannot be giving signal to start producing if there is the circulating red blood cells are normal, or if there is no blood loss, except if there is issue, like polycythemia, where the number of red blood cells are there. The erythropoietin will keep producing, but that's a clinical issue that equally needs attention. So when a person who has lived at high altitude moves to a sea level environment, production of erythropoietin is suppressed. Yes, we said at when there is hypoxia, there's increased production of red blood cell. But this one is that at high altitude, the hemoglobin level is low. But when this person now goes to a sea level, the erythropoietin production is suppressed. The rate of red blood cell count falls until the normal sea level value is achieved. So it's wonderful. That's the way God made it. With the loss of 1 pint of blood, the erythropoietin mechanism is activated. Once there is loss of blood, or even maybe that somebody, maybe a donor, some people they will be afraid. Maybe they will think if they donate, they will die. No, the way it's being made is that once there is loss of blood, assuming you donated to save a life or to save a patient, what your bone marrow does is that it will quickly, what your system does is that your system will, the signal sent to the kidney, from the kidney, erythropoietin is produced, transported by the plasma, then to the bone marrow, bam, it will compensate for that blood loss. Red cell production is enhanced, and within a few weeks, the number of circulating red cells has been restored to the normal value. The precision of control is wonderful. Yeah, it's wonderful. So that the number of the new red cells produced accurately compensate for the number of cells lost or destroyed. So when the cells the number of cells removed will also be compensated by the number of cells that are produced. So erythropoietin has been produced in vitro, a technique known as a genetic engineering. All right, let's look at how the red cells are destroyed, the lifespan of the red cells. Survival of the red blood cells in the circulation depends upon continuous utilization of glucose for production of energy. There are two chemical pathways that are employed. Both are essential for the normal life of the red cells. An extraordinary number of enzyme systems participate in this reaction and direct the energy evolved into appropriate uses. Red cells contain neither a nucleus nor RNA necessary for protein synthesis. Yes, we mentioned earlier that red cell does not have hemoglobin. During maturation, the nucleus progressively becomes smaller, and as it enters into circulation, it has lost within few days. It has lost its nucleus, and then enters into circulation to do its function. All right. Oh, another thing we need to know is that is the lifespan of red blood cell. The red blood cell has an average lifespan of 120 days. So the red cells cannot synthesize protein. We've said mitosis, that cell division, does not occur. Yes, it cannot, it doesn't, it's not maybe when it ages, it will multiply again. No. What it does is that these red cells, as they age, as they wear and tear, it will lead to loss of some of their proteins. Yes, some of their proteins will be lost, and the ability of some of their essential enzymes decreases. The activity of their enzyme decreases. So chemical reactions necessary for the survival of the red cells are consequently impaired. So because these cells are aged, the aging of the red cell, that is what we call senescence. Senescence is the process whereby cells age, they can no longer divide. Mitosis does not occur, even though they don't die, but mitosis cannot occur again because they are aged. So if the chemical reaction that normally occur are impaired because of the aging of the red cell, what happens is that water will now pass into the aging red cell. If water passes through it, it will change its shape from biconcave shape to a sphere. The red cells the shape will now change. Instead of being biconcave, it becomes a sphere. So these spherocytes are no longer elastic, so they become inelastic, and they will sluggishly move through the circulation. It is no longer the way the blood is being transported, they will just be moving sluggishly. Because of this, they will now be engulfed by phagocytes. In fact, when the phagocytes see they will engulf them. So phagocytic cells form a part of the lining of blood vessels, particularly the spleen, liver, and bone marrow. These cells are called macrophages, and they are part of the reticuloendothelial system. So they are found in the lymph node, in the intestinal tract, and they move freely. They are seen as free wandering and fixed cells. As a group, they have the ability to ingest not only other cells but also many other microscopic particles, including certain dyes or colloids. So the cells of the reticuloendothelial system, they are wonderful. In fact, one major thing that spleen does, which is part of the endothelial system, is that it acts as a filter. It filters the blood. It does quality control to the blood, such that the blood that will be transported, that will be supplied, it's not just the immature red blood cell. The aged red blood cell are trapped by the spleen. In fact, once you see them, it will trap them and will now allow the normal red blood cells to move. That's why in case of abnormalities like sickle cell anemia, that the shape of the cells are sickled, that's why normally they have crisis, because the blood doesn't flow. The spleen will engulf most of these cells, leading to them having issues in blood flow. Erythrocytes are rapidly destroyed by the reticuloendothelial cells, especially the spleen. So protein, including that of the hemoglobin, is broken down, and the component amino acids are transported through the plasma to be used in the synthesis of new protein. So this is how the red cells are more or less recycled. The ion removed from the hemoglobin passes back into the plasma. The ion now goes back to the plasma and is transported to the marrow, where it may be used in hemoglobin synthesis in newly forming red cells. Yes. So this ion, not necessarily for the ion that is not necessary for this purpose, is stored within the reticuloendothelial cells, but is available for release and reuse whenever it is required. So it is not all the ion that are used. Yes, to avoid toxicity or whatever. So in breakdown of red cell, there is no loss to the body of either protein or ion. The protein is not being lost, the ion is not. It will pick the ion that will be used, and the other one stored in the reticuloendothelial cells to be used later, virtually of which is conserved and reused. This is so wonderful. It's more or less, it recycles it, unlike in porphyrin ring structure of hemoglobin, to which the ion was attached and undergoes a chemical reaction where the ion will be excreted from the body. So this is how the red blood cells are produced in the body. We've mentioned the lifespan, we've mentioned how it is destroyed, how the hemoglobin part, the heme parts, the ion parts are recycled. The ion parts that is not necessary for the new synthesis will be stored in the reticuloendothelial cells. So this is wonderful. In this case, it's not something that one will begin to bother and say, I need to go to convenience to remove my damaged red blood cell. God made it in such a way. The cells are produced, and if they live up to 120 days, which is their lifespan, it will destroy, it will recycle itself. And one wonderful thing that happens in this process is that the production of red blood cells in the bone marrow, the bone marrow is always at its peak When he receives a signal that there is blood loss or hemorrhage, or in case of accident, something happened and the patient is bleeding, it does a compensatory mechanism. The number of red blood cell that is being destroyed, it will produce to compensate it. Yes, but if the hemorrhage continues and is not being controlled, continuous loss, anemia might ensue, and that might cause a havoc if not properly handled. So thank you so much for following up to this point. I still remains your friend, PromiseUkamaka, a medical lab scientist, a healthy life advocate,